All right, and welcome back. So in this video, we are going to be factoring a quadratic expression when we have a leading coefficient that is not 1. So we're going to have like 2 or -4 or 5. Previously, we've talked about how to factor a quadratic expression when that leading coefficient was 1. So it just looked like x squared plus 3x plus 2, right? But now we're going to be incorporating the same process, but now we have to include a leading coefficient, our a value, as not 1. So we're going to be going through a couple of different ways to do it. Your guided notes have a certain way, and I'm going to show you the way that I like to do it, and that's by grouping. I previously showed you how to use the grouping method with a leading coefficient of being 1, so last video, and the method stays the exact same when it comes to factoring a quadratic expression that does not have a leading coefficient of 1. It's going to have an actual number attached to our x squared. So without further ado, let's have out our guide notes and let's begin. So within the first example that your guide notes goes through is we're going to be factoring 2x squared plus 11x plus 15. And what we want to do is we want to find factors of 2 and factors of 15 that when we add them together, that's going to give us a sum of 11. So we have 1 and 2, 115. We work all the way through and we see that the factors of 2, 1 and 2, and the factors of 15, 3 and 5, when we multiply those together and then we add them, we get 11. So we can substitute them in to our two sets of binomials. We have x plus 3 and 2x plus 5. This is one way that you can go about it. If you want to use a different method, by all means go for it. So long as we end up in the same result, it does not matter. Let's go through how to use the grouping method, which is my preferred method of factoring. And again, you don't have to use this method. You use whatever method you want to use. We have 2x squared plus 11x plus 15. What I do is I'll multiply our a and c value together and we get 30. We now need factors of 30 that will add up to 11. We're going to find that 5 plus 6 is equal to 11. So we're going to go back into our original problem, and instead of writing 11x, we're going to write plus 5x plus 16x, because 5x plus 16x is 11x. And we're going to write plus 15. We can use our grouping method. So we can pull out in that first set x. We're left with 2x plus 5. In that second set, we can pull out a positive 3. And again, we're left with 2x plus 5. Since we have that matching set of parentheses, we can factor it out. 2x plus 5 times whatever was on the outside, x plus 3. And you're going to notice that we end up with the same answer as we did before. And again, we can check our work by doing that foiling process and ending up back where we started. Again, order does not matter. On the left, it's x plus 3 times 2x plus 5. And then the way that I did it was 2x plus 5 times x plus 3. It's the same thing. 2 times 3 is 6, and 3 times 2 is 6. Another example that is done for you is factoring 3x squared minus 23x plus 14. So we're going to find factors of 3 and factors of 14 that when we multiply and then add them, we get a sum of negative 23. We're going to find that 1 and 3 are the factors of 3, and negative 7 and negative 2 are the factors of 14. And we replace it in. We get x minus 7 times 3x minus 2. Again, if that method works for you, please, by all means, use it. For me, it's not my preferred. My preferred is grouping because it's the same for every single quadratic expression. So I'm going to multiply that a and c value, and we get positive 42. We need factors of positive 42 that add up to negative 23. Now, two numbers that multiply to give us a positive, both of them can be positive, or both of them can be negative. And now we need to think of factors of 42 that add up to 23. We're going to get 21 and 2. So we're going to replace. We have 3x squared now minus 21x minus 2x, because that is negative 23x plus 14. We can use our grouping method. we can factor out 3x from the first set. We end up with x minus 7. Now, previously, we've tried to factor out it to match those parentheses. We can try another way. We know we have to have a set of matching parentheses, and the current parenthesis is x minus 7. So what we can do is we can start out with x minus 7 this time and see, okay, what do we need to divide by to get x minus 7? In that second set, it's currently negative 2x plus 14, but we need to turn it into x minus 7. So in order for us to do that, we have to divide by negative 2. So let's just double check. Negative 2x divided by negative 2 is positive x, and positive 14 divided by negative 2 is negative 7. So therefore, we do have our matching sets of parentheses. We have x minus 7, and then times whatever was on the outside in blue, 3x minus 2. And again, you're going to see we end up with the same answer as before. We can check our work, and that's awesome. With this in mind, please work on problems 1 through 4 on the guided notes and resume when ready to go forward. All right, so let's do another example. So when c is negative, one factor of c is positive, and one of them is going to be negative. We can always stop checking factors when you find those that work. Let's say we have 2x squared plus 7x minus 15. Again, we need factors of 2 and factors of negative 15 that when multiplied together and added up, we get positive 7. We're going to find that 1 and 2 and 5 and negative 3 are going to be those that add up together to give us positive 7. So we replace it in, we get x plus 5 and 2x minus 3. If we were to do the grouping method, it's a little bit tight on the right-hand side, but that's okay. We're going to write our original problem. Multiply our a and c values, and we get negative 30. Now, since we have a positive b value, that means the factor that is bigger has to be positive. So we need one negative and one positive. So let's just try to determine what it's going to look like. I put that in the wrong spot. So we need positive 7. Well, we need to think two factors that when we subtract them, we get 7. Well, 6 and 5 don't give us it, but 10 and 3, if we do 10 minus 3, that's going to give us 7. So it needs to be positive, which means that we're going to have negative 3 and positive 10, because negative 3 plus 10 is positive 7. So we're going to go back into our original problem and replace it. We have 2x squared minus 3x plus 10x minus 15. We can do our grouping method. We can pull out a x in that first set. We end up with 2x minus 3. In that second set, we can pull out positive 5, and that should match now. End up with 2x minus 3. We have a matching set of parentheses. We end up with 2x minus 3 as one of our factors, and then x plus 5. And as you can tell, it is the same as we got over on the left-hand side. We can always check our work just to make sure that we ended up where we started. Awesome. Let's go through one more example through your guide notes, and then I'm going to show you the way that I do it. So we're going to factor negative 5x squared plus 28x plus 12. We like to keep that a positive. So in order to keep that a positive, we're going to divide out by negative 1. But we don't have anything equal to, so it has to be factored out as negative 1 times 5x squared minus 28x minus 12. We can't divide everything by negative 1 because we don't have an equal sign. So we still have to include that value of negative 1 on the outside of our quadratic. And then from here, we need to find factors of 5 and factors of negative 12 that when multiplied together and added, we get negative 28. We're going to find we get 1 and 5, negative 6 and 2. And now notice here, we do include that negative 1 because it's still part of our problem. If it wasn't part of our problem, when we check our answer, it's not going to match what we started with. We do then end up, because we included that negative 1, back with the negative value at the end. If we were to do this using the grouping method, though, Again, we like to keep our a value positive, so we're going to factor out -1, end up with -1 times 5x squared minus 28x minus 12. We need to multiply our a and c value. We get -60. So we need to think of factors of -60 that when added together gives us -28. Since I know I have this current value is negative, one factor has to be positive, one factor has to be negative, and since we have a negative b value, the bigger factor is going to be negative. So let's think of what two factors of 60, when subtracted, gives us 28, 30, and 2. So that means we have +2 and -30, because 2 plus -30 is -28. So we end up with 5x squared plus 2x minus 30x minus 12. I included brackets because I don't want to confuse myself with some of these parentheses that we use when we group. In that first set, we can pull out just an x. So we end up with 5x plus 2. In that second set, remember, we want to end up with 5x plus 2. We want that to be our matching. So in order for us to get that, we have -30x. That has to change into a positive 5x, which means we have to divide out by -6. Let's just double check it works for that -12. Well, -12 divided by -6 is +2. Therefore, we get -1 times the matching parenthesis, which is 5x plus 2 times x minus 6. And this is our final answer. Awesome. With that in mind, please work on problems 5 through 7 on the guided notes. Y'all have been doing super duper well, and we're going to be continuing our conversation in just 1 minute. So we are going to be now talking about how to solve these quadratic equations. So we're going to be solving these quadratic equations by the factoring process. We just went through how to factor a squared, plus bx plus c, and now we're going to be talking about how to solve it, because now we're going to have an equal sign. It's going to get real fun. So quadratic equations can be solved by factoring and using the zero product property. If the product of two quantities equals 0, at least one of the quantities must equal 0. By the way, this is 8.6. I apologize. I didn't actually tell you where to go in your guided notes. This is section 8.6. And this is called the zero product property. It's going to be very helpful for us. Let's just think about if x times y is equal to 0, then x is 0 or y is 0. We're going to be using this idea to help us solve when we have these factored products. So if x plus 3 times x minus 2 is 0, then either x plus 3 is 0 or x minus 2 is 0. And the reason that we have this or is because we can't find a value of x that's going to, when we add 3 to it, gives us 0, and at the exact same time subtract 2 to it and give us 0. This is why we call this zero product property. We're going to separate them and set them equal to 0 and go from there. So we're going to use a zero product property to solve x plus 8 times x minus 5 is equal to 0. So we're going to break it apart into x plus 8 is equal to 0 or x minus 5 is equal to 0. We're going to solve these just like we normally would if they were equations. On the left-hand side, we subtract 8. On the right-hand side, we add 5. Therefore, x is equal to -8 or +5. And we can always check our work by plugging it in. So x is -8. Well, then -8 plus 8 is 0. And if x is 5, well, 5 minus 5 is indeed 0. Awesome. With this, please work on problems 1 through 6 on the guided notes and resume when ready to move forward. All right, so sometimes we need to factor before we can use that zero product property. So let's say we have x squared plus 4x minus 5 is equal to 0. We're going to solve it by factoring. So we're going to factor x squared plus 4x minus 5. And that's still going to be set equal to 0. And you can use whatever method you like in order to solve this. You do whatever method you want to. When we end up with x plus 5 times x minus 1 is equal to 0. So that means that x plus 5 is equal to 0 or x minus 1 is equal to 0. And when we solve, we get x is equal to negative 5 or x is equal to positive 1. And when we check it, come on, we can do it. There we go. When we check it, we plug it in to our original quadratic, and we will end up with 0 when x is negative 5, and we'll end up with 0 when x is positive 1. Awesome. And now we have 3x squared minus 12x plus 12. We want to solve that again by factoring. So in order for us to do that, we have to actually factor 3x squared minus 12x plus 12. We're going to end up with the greatest common factor coming out first, which is 3. So now we have x squared minus 4x plus 4. That's equal to 0. And we're going to end up with 3 times x minus 2 times x minus 2. Again, this x minus 2 times x minus 2 came from factoring x squared minus 4x plus 4. We want to pull out that greatest common factor in the beginning to make factoring a heck of a lot easier. When we solve it, we know that 3 cannot be equal to 0, and we have x minus 2 is equal to 0, therefore x is going to be equal to 2. In this case, since we are having it equal to 0, we technically can divide by 3 on both sides, since we know that 3 cannot equal 0. So we just end up with x minus 2 times x minus 2. In any case, if you can factor out that greatest common factor, it's going to be a lot easier for us to then go ahead and solve. When we're ready, we can check our work. We can substitute in the value of x being 2, and then from there, we'll see that we get 0. Before we go to our guided notes, I want to just pull up another general idea. Let's say we have 2x squared plus 6x, plus 8 is equal to 4. We can't solve this just yet. In order for us to solve it, we have to have it equal to 0. So now we're going to end up with 2x squared plus 6x plus 4 is equal to 0. Now we can factor. We can't factor if it's not equal to 0. So it has to be equal to 0 in order for us to factor, because we want to eventually use that zero product property. And in order to use a zero product property, we have to be equal to 0. So there are going to be some times where you have to equal it to 0. Awesome. Thank you. Now with all of this in mind, please work on problems 7 through 15 on the guided notes. Y'all are doing a fantastic job. Keep up the great work. I'm super proud of you, and you should be really proud of yourself. If you have any questions, please let me know. I'll talk to you soon.